This video is about inverse functions. It could take 2 videos to get through all of this material, so we'll see. The inverse of a function is the reflection over the line y equals x. That's a graphical way to look at inverses, and that's what I want to start with. Here's my original f of x, that's the red. The blue is my g of x. And the green line in the middle is my line y equals x. If we had a piece of paper and we folded this right on this green line, this red function would land exactly on the blue function. The reason this works as far as flipping over this line, this is a line y equals x. That implies that your y value should become your x value, and your x value should become your y value. So take a look at this ordered pair right here. This is the ordered pair 0, 2. What's this ordered pair right here? 2, 0. Up here, this looks like it might be about over 1 up 4. 1, 4, it becomes 4, 1, and that's that point right there. I could do that for every single point on the red curve. Swap your x and your y, and it becomes the points here on the blue curve. We're going to talk more about those points at the end of the video. Now, notation-wise, f negative 1 of x is the notation for the inverse of a function, f. Go back to this. This does not mean we're multiplying f by negative 1. It is just notation. When you see this notation, that's telling you you are talking about the inverse of a function. Now, because we're going to be doing some swapping of x and y algebraically, the domain of f is equal to the range of the inverse of f and vice versa. Because x and y change, the domain and range will change. So if you need to verify the two functions are inverses of each other, what you must show is that f of g of x equals x, and you must show that g of f of x equals x. You've got to do them both. So directions say show that the two functions are inverses of each other. What I have to do is the f of g of x that we learned in the last section. So f of g of x means I'm going to put in place of g of x, I'm going to put x minus 2 over 3. F of that means for me to plug this in for that x. So this is going to be 3 times x minus 2 over 3 plus 2. The 3 times this, the 3's are going to cancel, and we get x minus 2 plus 2. The negative 2 and the positive 2 cancel, and we really do get x. That's only half of the story. We've got to go the other direction. To do g of f of x is 3x plus 2. So we are going to put this entire 3x plus 2 in place of that x. So I put 3x plus 2, and then the rest of the function looks the same. In this case, 2 and negative 2 cancel. Now we have 3x over 3. The 3's cancel, and we get x. Because f of g of x equaled x and g of f of x equals x, we can say that these two functions are inverses of each other. And since they are inverses of each other, instead of using the g of x notation, I can now use f of negative 1x to show that they are inverses of each other. Another one, f of g of x, I'm going to have to put in place of the g of x what it's really known as, x plus 7 over 4, and then evaluate f of that. F of that means to take this whole thing and plug it in for x. So 4 times parentheses, x plus 7 over 4, minus the 7. The 4 times the parentheses, the 4 here and the 4 here cancel. So we have x plus 7 minus 7. The 7 and the negative 7 cancel, and we get x. So we're looking good on that front. We've got to come back and do it the other direction. So g of f of x is 4x minus 7. We're going to take this quantity and plug it in for that x. So this will be 4x minus 7 plus 7 over 4. Our negative 7 and 7 cancel up top. 4 over 4 cancels, and we get x. Because f of g of x equals x and g of f of x equals x, we can now use the inverse function notation and do our f negative 1x equals this x plus 7 over 4. Another type of problem you're going to have to deal with is to actually find the inverse of a function. The first couple screens, I gave you two functions, and we checked to see if they are inverses. Now, you're going to actually find the inverse algebraically, and it's pretty easy. First off, you're going to replace f of x with y, and then swap your x and your y, and then solve for y. If the resulting equation is not a function of x, you're going to stop. So here's f of x equals 3x minus 4. The first thing you want to do is, in place of this f of x, put y. So that's a simple step. The next is we're going to reverse our x and our y. Put x over here and put y over there. What's left is just to rearrange this and get this solved for y. Do your regular algebra to get the y alone. First thing we'll do is add 4 to both sides, which is going to give us x plus 4 equals 3y. To get the y alone, divide both sides by 3, and we now have this. Is this a function? And the answer is yes. It's linear. So I can replace the y with the function notation of f negative 1 of x. And that is my inverse function. Placing y in place of f of x, then we're going to swap out our x and our y. Let's solve this for y using basic algebra. I have two choices. I could subtract 3 from both sides, or I could get rid of the fraction first. I choose to get rid of the fraction by multiplying everything by that denominator. So that's going to give me 2x. Those 2's cancel out, give me y plus 6. Just subtract 6 from both sides, and you have that. Is that a function? Yes, it is linear, so I know it is a function, and I can use my inverse function notation right there. F of x equals x cubed plus 1. Let's replace f of x with y. Swap out your x and your y, and then solve this for y. Very easy to solve. Start by subtracting 1 from both sides. And then this is y cubed. The only way to undo y cubed is to do the opposite, which is the cube root. So I do the cube root of both sides. And you have to ask, is that a function? And the answer is yes. Now, how do I know these are functions? Well, the idea on a function is that for each x value, you get exactly one y value. No matter what x value you get in here, you get one y value that goes with it. So because it is a function, I'm allowed to use my function inverse notation. F of x equals x squared. Replace f of x with y. Swap your x and your y, gives you x equals y squared. To undo squared, we need to do the opposite, which is square root both sides. But remember something important. When you solve an equation by taking the square root, you pick up a plus or minus. Is this a function? No, because if I put, let's say, 4 in here for x, if x is 4, this says plus or minus of that. That means 4 goes with 2, and 4 also goes with negative 2, which means this is not a function. Because this equation does not represent y as a function of x, the original function, which was this, does not have an inverse function, and therefore we don't use our function notation because it's not a function. And what you have to think about is the function has to provide exactly one output for each input. Like I showed you up here, the input of 4 gave me an output of 2, or it could have given me an output of negative 2, and that's why this is not a function. Now on the next screen, we're going to look at something graphically that might help you keep straight about what's what here. Here's the graph of f of x equals x squared. I've already drawn in the line y equals x because we're going to look at this graphically piece by piece. We're going to try to reflect this whole parabola over that blue line, and we're going to take it piece by piece. If I just look at this little piece right here, if I reflect that little curve over that line, then we're going to end up with this. This reflects over to here. Now look at this part. Reflect this over that line. It's going to come over here. So we've got that part. I can smooth it out a little bit, but you got the idea. Now reflect this over the blue line, and this is what you get. Put that all together, and we've got a problem. We have a sideways parabola, and we know that if we draw in any vertical line, if that vertical line crosses the graph more than once, it's not a function. So the inverse of this parabola became a sideways parabola, and that sideways parabola failed the vertical line test. The red is not a function. Now think about something. If we took this parabola here and we rotated it back where it was originally, that means this original function would have had a horizontal line drawn through it. Looking at a horizontal line ahead of time can tell us if our inverse will actually be a function. A function f has an inverse that is a function if there is no horizontal line that intersects the graph of the function at more than one point. This was my original function. I draw a horizontal line. That horizontal line is crossing my original function twice. What happens when we reflect that over the blue line, we're going to end up with something that fails the vertical line test. How does this horizontal line test help us? Well, if you have a visual, meaning maybe you've typed it into your graphing calculator and you can see what the original function looks like. If you can see that that original function will fail the horizontal line test, then you know that that original function does not have an inverse that's a function, and you don't have to take the time to do the algebra on it.